Let's begin. Today's September 19th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 7, 11, 14, 18, and 19. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our last digit, the circle digit, and will let us know whether it's an even digit or odd digit. Criteria card B looks at our first 2 digits, triangle and square, and compares them. So should the value of triangle be less than square, should they be equal, or should triangle be greater than square? Criteria card C will take a look at our 3 digits, triangle, square, and circle, and will let us know which one is the absolute smallest. So should triangle be the smallest, should square be the smallest, or should circle be the smallest? Criteria card D, again, looks at our 3 digits, triangle, square, and circle, but this time it'll add them up, and the Turing machine will let us know if that sum is an even quantity or an odd quantity. And finally, criteria card E will take our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? And remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So first, before we start, I can only remember maybe one other puzzle that uses all cards that have only the digits symbolized on the criteria cards. You don't have one of these where, is there no even, 1 even, 2 evens, or so forth. So very interesting setup here. Okay, so let's actually start off with testing criteria card A and figuring out if that circle digit is even or odd. Okay, so the Turing machine does not approve of my choice for circle. I did choose an even 4. Since the Turing machine disapproves of it, it's letting me know that circle should actually be odd. So let's go ahead and type that up in our notes for section A. And that again is that circle is an odd digit. Okay, and since it is odd, let's go ahead and cross out the evens for circle. Okay, the next thing I think I'll test is criteria card D. Okay, so again, the Turing machine does not approve of my proposal. Recall that criteria card D is adding up all the digits, so let's go ahead and do that with my proposal. And so 3 plus 1 is 4, 4 plus 4 is 8. 8 is an even quantity, but the Turing machine does not approve of that. So it's letting us know that the sum of the 3 digits should actually be odd. So let's go ahead and type that up in section D. And that is that triangle plus square plus circle should be equal to an odd quantity. Okay, so let's take a look. So we've already established that circle is odd. So the way to have a total sum that is odd is that triangle and square must be of the same type, meaning they're either both even or they are both odd. And that's because whenever you add digits that are of the same type, again, 2 evens or 2 odds, that sum is even. But then if you add this last odd digit, that will establish that the total sum be odd. Okay, So we're looking for either two evens or two odds in triangle and square. So it is kind of interesting that they do have in criteria card B the fact that they're equal. Now here's an interesting thing, is if you do have two equal values, that means that the non-paired up digit would have to be the smallest. So if we do have a pair, it can't be a pair of ones. We know that much. Not that we can cross them out, because we don't know how they're paired up. It may not even be triangle and square. But we know that we can't have any pair of ones. So there may be a pair of twos, threes, fours, or fives. So let's take a look. What else? Even though obviously I don't have triangle and square as equal, it does kind of pique my interest. I'm just trying to figure out if they are equal. And we also have this criteria card E that tells us the sum. Could they be, equal to 6 and they're both 3, 3? And therefore circle may be forced into being a 1. Oh, well, the other thing we can say, I suppose, let's see, can we cross out circle 5? No, not really. We haven't established that the first two are equal. So no, we could still pair up the 5 with another 5 and, either triangle or square be smaller. Wow. Well, let's go ahead and test criteria card E. Okay, so the sum is not less than 6. So either we have a sum that's equal to 6 or greater than 6. So let's go ahead and type that up in section E. And that again is that triangle plus square is either equal to or greater than 6. Okay, well, that does it for this round. We did our 3 Turing tests. Now we're moving into the phase of how to construct a good second round proposal. What I may have neglected to at least state something about, could we have done anything, crossing out any digits in triangle or square after knowing this? And I believe not. Because if we do have something that's equal to 6, we can still use a 1 or a 5, and greater than 6, 2 and 5 work. There's just too many options. I don't think there's anything we can definitively cross out. So that it was informative as far as, at least we reduced it by one option. But did not really help us in crossing out anything. Okay, so let's go ahead. So it would be interesting, if they were equal, and they'd have to be either equal to 6 or greater than 6. Well, the obvious choice would be equal, and they both 3 and they're 6. So that would force circle to be 1. Now, I guess, let's see. Can we make an argument, like, if they are equal? I would almost say that, I think you can say that they can't be equal, because if they were equal, then that would force circle to be the smallest. Absolutely, like we stated, whenever you have a pair of digits, regardless of which one it is, technically, the paired up digit, if you have this criteria card C for the smallest, would indicate that that third digit has to be the smallest. So I'm almost thinking that no, they're not equal. So I don't think it's going to be a 6. So it's going to be something bigger than 6. And, you know, can we, if they are, well, let's see, if they're going to be equal, well, I'm sorry, if they're both going to be evens or both odds, what can we have? We can have something that sums up to 6, right? We could still have a 4-2, and maybe that's what it's going to be. They're going to add up to 6. Let's see. Are there just too many possibilities? Why not 5-1? Yeah. I like the idea of it being 4-2, but how do you guarantee that it's that you're using evens? What about if it were greater? So it could be even 2-5. Yeah, I don't see some sort of a distinct solution that, you know, could be made using different criteria cards. So let's go ahead and let's see. It would be interesting that if the sum of the first two is greater and somehow one of them is still the smallest, that'd be very interesting. But how, I mean, even 2-5 gives you something that's greater, and 2 isn't that small, or too big. So, and again, you need to start kind of crossing out some possibilities. Okay, let's go ahead with, we'll do 5-3-5. See where that takes us. Okay, so I did choose to go with a proposal where the sum is greater than 6. So let's go ahead and retest criteria card E. Okay, so yes, it is true that the sum of the first two digits is greater than 6. So let's go ahead and update our notes. So we know it's not equal. And so now we can definitely cross out the 1s, because even adding the largest 5 to a 1, that's 6. So it's not big enough. So let's go ahead and cross out 1 for both triangle and square. And that seems to be it. We can add a 2 and a 5, and that's already greater. Let's see. What about the smallest? Yeah, let's go ahead and let's see. Does that tell us anything? So I guess at this point, the only way we can have evens is if we have 4-4, because we know 2-4 and 4-2 are already disqualified because they both add up to 6. So we'd have to have 4-4, again making circle the smallest. But then now, how do you pick between 1 and 3? I don't think you can. So I don't think it's going to be 4-4. And so that would almost seem to disqualify all the evens for triangle and square. So it may come down to if square is the smallest. Let's go ahead and do that. Let's try criteria card C. Okay, so square is not the smallest. So let's go ahead and type that up. That was for criteria card C, but we'll write it up as either triangle or circle is the smallest. So let's go ahead and type that up. And that's in C. So either triangle or circle we'll say is the smallest. Okay, so let's see. So square is not the smallest. I don't think you can cross out anything, honestly, because, there is a 1 for circle. So let's see. Well, let's go ahead and test criteria card B. Okay, so it's also not true that, let's see, what did I choose? I chose a triangle that's bigger than square. So that's not true. So either they're equal or triangle is smaller than square. Okay, so let's go ahead and type that up, and that is that triangle is either equal to, just experiencing a little bit of lag, there we go, is either equal to or smaller than square. Okay, so I think we should be able to cross something out. So we know that triangle cannot be bigger. So yeah, I think we can cross out triangle as 5 because of, well, let's see. You know what? Maybe we can't even cross out anything because of the equal, right? 5 could equal to 5. Very interesting. Yeah, we can't cross out anything because of the equal. Yeah, okay, wow. So let's see. Okay, so we did complete our 3 Turing tests, and we're really not any closer to having a solution. So let's see, what can we, we'll have to rethink our approach here. So we still do have triangle and square are definitely bigger than 6. And remember that we do have to have 2 evens or 2 odds. So again, I don't think it's going to be 4-4. So I think I have to kind of establish that fact, because if it were 4-4, yes, circle is the smallest, but which one would you pick? There's nothing else in our list of criteria cards to help us decide between 1 and 3. Okay, so we know we have an all odd solution. And so let me go ahead and cross out the evens just so that I can focus on the odds and see how to construct a good 3rd round proposal. So no evens. Okay, so we know that triangle is not bigger. So I think, again, I don't think we can even have triangle and square to be equal, because again, how would you choose between 1 and 3? So they're not equal. So I'm going to deduce that triangle has to be smaller than square. And so if triangle has to be smaller than square, it's going to be 3, 5. And we do have to have a smallest. So among 3 and 5, the smallest would be 3. So it would seem that the solution would be 3, 5, 5. And there again, I would be deducing that triangle is the smallest. I'm going to go with 3, 5, 5 as a solution. So let's go ahead. And so let's take a look. Again, I am making certain deductions. I just hope they're not in haste. Yes, the last digit is odd. Here I am deducing that triangle has to be smaller than square, so yes, 3 is less than 5. Again, I'm deducing that triangle is the smallest. It is. The sum is odd, and the overall sum is odd. That's true, and the sum of the first two is greater. Well, let's give it a try. So 3, 5, 5. Okay, 3, 5, 5. Okay, so yeah, that was incorrect. Okay, so yeah, my deductions did not pay off. Maybe perhaps done in a little bit of haste. So let's go ahead and let me just do something really quick. Okay, so what can we'll have to come up with a new proposal. So yeah, so the game is lost, or I lost since I made a bad choice. So let's go ahead and let's see, what could we do instead? Maybe circle is the smallest. I guess I may have assumed that there had to be a pair. There's nothing that says there has to be a pair. But I guess, let's see, if triangle were smaller, and you'd have, say, 3, 5, I guess it could be 3, 5, 1. Yeah, that's the only way where you could avoid having to pick a 3. Again, it's not that there can't be equals, it's just that the 3, 5, there has to be something smaller than 3. Maybe that's how circle is the smallest. It's 3, 5. Let's see, 3, 5, 1. Yeah, I'm not sure. I just got maybe this stuck in my head that there had to be a pair. So circle's the smallest. Let's go ahead and do 3, 5, 1, and we'll test B out. Let's see, 3, 5, 1. And let's test B. Okay, yes, it is true that triangle is smaller than square. Triangle is smaller than square. So let's go ahead and cross this out. Yeah, it's going to be 3, 5. So let's go ahead and cross out 5 for triangle. And let's go ahead and cross out we're going to have to cross out 3 because the sum has to be greater than, so it can't be 3, 3. Okay. And so we got that. Now, in order for 3 to be the smallest, we'd have to pick 5, 5. So why did that get, because circle is probably the smallest. And so I guess, let's go ahead and test C and confirm that circle is the smallest. Yeah. Oh, yeah, circle is the smallest. So yeah, if we have 3 for triangle, 5 for square, obviously it's got to be smaller than 3. So yeah, so that's why, wow, quite challenging, and I probably didn't help myself by making certain bad decisions. So let's go ahead and type that up of 351, and we'll verify one more time. Okay, so 351. So let's go ahead and verify one more time here. Yes, circle is an odd digit. Triangle is smaller than square. Yes. We already established that it was a circle that is the smallest. So let's go ahead and see how is this going to work. Okay, so yeah, that leaves circle to be the smallest. The overall sum is odd, and yes, the first 2 digits do add up to be something greater than 6. Yeah, okay, well let's just see one thing. So we already established B and C to be correct, E to be correct, D, even though it was wrong, it was a 50-50, so we know that's odd, and same thing with A. Yeah, so that should be it. Let's test it one more time. And so it's 351. Oh, this is interesting. Okay. Yeah, so this time it was correct. Okay, well let's see. Even though I lost, let's go ahead and see how we compare to the Turing machine. So we did do, so this is 5 criteria cards, 8 tests. So let's see, what did we do? We did A, D, E in the first round, and then we did B, C, and E in the second round, and E was the only correct one, and then B, C was correct. So let's go ahead and type that up, A, D, E. So A, D, E were incorrect. And then we tested B, C. Oops, sorry. Those were also incorrect. And only E was correct. And then finally, yes, B and C were both correct. Okay, wow, look at that. It did it in 6 questions. And yeah, obviously maybe towards the end I was not too confident, so maybe I did do 1 extra test, but still 6 questions. That's amazing. Okay, so yep, this time around did not do as well as I'd hoped. But if you saw any inefficiencies other than the ones that I pointed out, please do add those to the comments. If you like the video, give it a thumbs up, and of course, hit subscribe to be notified of any future videos. Well, until next time, have a great one.